Every item crossing an ocean, highway, or warehouse floor sits on one thing, a shipping pallet. It is the literal foundation of global logistics. This chart shows the financial scale. In 2021, the global pallet market reached an $82 billion valuation. By 2027, that number is expected to hit $110.5 billion. To meet demand, 10 billion pallets are in circulation right now. 95% of those 10 billion pallets are made from standard wood. Supplying that much wood requires massive scale. Pallet production currently uses 43% of all U.S. hardwood and 15% of softwood, driving significant deforestation while relying on toxic chemical pesticides to prevent insect infestations. Because of the way they are manufactured, wooden pallets break frequently. The industry assumes a 10% loss rate every single year. When they break, very few are actually recycled. Most end up here, in landfills, because retrieving them and processing them for reuse is logistically complex. These pallets take up to 13 years to decompose. As they rot, they release concentrated methane gas, a greenhouse gas 86 times more potent than CO2 over a 20-year period. This creates a dilemma for logistics managers. They are caught between skyrocketing sustainability mandates and a logistics network that runs on this high-emission standard. Today, we will directly compare that traditional wood standard against virgin HDPE, recycled HDPE, and a novel waste-based composite called UBQ. Relying on standard wooden pallets trades cheap, short-term procurement for high-risk breakage and maximum carbon emissions. This matrix will evaluate these materials based on their input sources, their carbon footprint per pallet, and their operational lifespan. Wood sets the baseline. Factoring in timber harvesting and manufacturing, a single wooden pallet generates over 1,401 kilograms of CO2 equivalent emissions. Transitioning to oil-based plastics is the most common alternative, starting with virgin high-density polyethylene, or HDPE. Virgin HDPE requires the extraction of fossil fuels. The energy required to produce these resins carries its own heavy environmental footprint. On the matrix, you can see that virgin HDPE drops the footprint significantly compared to wood, down to 78.66 kilograms of CO2 equivalent per pallet. Using 100% recycled HDPE cuts that number in half again, down to 39.29 kilograms. Both plastic types offer a massive durability advantage. They can travel more than 200 round trips before they are taken out of service. In this scenario, you gain extreme operational durability and eliminate the risk of pests or termites. However, virgin resins require fossil fuels, and post-consumer recycled plastics often struggle with global supply volatility and inconsistent quality. Traditional plastics solve the physical durability issues of logistics, but they fail to adequately address the Scope 3 emissions required by modern ESG standards. Our final contender, pallets manufactured using a blend of recycled HDPE and UBQ. UBQ is a bio-based thermoplastic converted entirely from unsorted municipal solid waste. That includes mixed plastics, paper, cardboard, and organics like food scraps. Advanced technology breaks this waste stream down into basic particles and reconstructs it into a new, consistent thermoplastic matrix. This composite is delivered in standard pellets, compatible with all major polymers. It requires zero retooling or adaptation costs for existing factories. By substituting just 10 to 15% of the resin with UBQ, the carbon footprint of the pallet plummets to just 11.04 kilograms. This works because the material formulation itself is climate positive, reducing environmental harm compared to the baseline. Every ton of UBQ diverts 1.3 tons of landfill waste and prevents up to 11.7 tons of CO2 equivalent emissions. The trade-off here is a move away from the familiar wooden standard toward a highly advanced composite material. Swapping to a UBQ composite turns a shipping pallet from a carbon liability into a climate-positive, highly durable asset without disrupting existing manufacturing systems. If the logistics industry replaced wooden pallets with a 50% UBQ composite, it would divert 26 million tons of waste from landfills. Over a 10-year period, this transition would result in over 1 billion tons of avoided CO2 emissions across the global supply chain. This diagram illustrates the transition from a linear to a circular economy. In the linear model, raw materials are extracted, consumed, and dumped into methane-emitting landfills. In the circular model, Organic waste is converted to UBQ, used for hundreds of trips and recycled without degrading. Is this transition right for every single logistics operation? Not if you run a purely open, fragmented supply chain, where pallets are shipped one way and immediately lost. It is impossible to justify the financial return on a high-quality 200-trip asset if your network treats it as a single-use disposable that vanishes. However, this is the perfect solution for closed-loop supply chains, where pallets are routinely retrieved and reused. In a closed loop, the slightly higher initial procurement effort yields exponential long-term savings on breakages and unparalleled reductions in Scope 3 emissions. Integrating UBQ is a strategic mandate for leaders who want to permanently decouple their supply chain's growth from environmental destruction.